Hello, good morning to all who have joined the webinar. We'll be starting the webinar in a minute or so. Just let people settle in. Right, I see a nice growing list here. So we'll start like here in a few seconds. All right, thank you all for joining. Hello, my name is Rajesh Polapragada. I'm a digital transformation architect at PDSVISION, and I've been working in the product development space for the last 20 years, helping companies realize how they can use technology as an enabler in their digital transformation. So this is a little bit about PDSVISION. So we're the largest reseller of PTC, and PTC makes technology actually in the digital thread space that helps companies with their digital thread journey. And we operate out of 13 countries. We're over 400 employees worldwide, and then serve over 4,000 customers now overall across all the geographies. So a few housekeeping notes before we start our session. So this is going to be a listen-only webinar. There is a Q&A panel in the interface in GoToWebinar. So I request that you post your questions there, and I'll take them as as this discussion goes along. With that, let me introduce the star of the show. I'm really excited for today's topic and our guest speaker. The topic we'll be discussing is one in the series on Factory 4.0. In this episode, we are going to be focusing on people, the skills that makes Factory 4.0 real. Right. So now I'd like to introduce our guest speaker, Dr. Ragu Adinarayanan. Dr. Ragu Adinarayanan is a distinguished professor of smart manufacturing and industrial informatics at Purdue University in West Lafayette. He holds a BS and MS degree in electrical engineering, along with a PhD in engineering science from Southern Illinois University. Recognized as an expert in his field, Dr. Adinarayanan is an esteemed member of the World Economic Forum and the World Manufacturing Forum, contributing valuable thought leadership on intelligent manufacturing and the transformative impact of data and AI on the future of manufacturing. His primary research focus revolves around data-driven smart manufacturing with specific interests in systems optimization, zero-defect manufacturing, and predictive maintenance. Dr. Adinarayan's leadership extends to establishing 4 research centers at Purdue University, each focused on transferring cutting-edge technology into industries. One of his recent achievements includes leading the development of the DOE CSMI Smart Manufacturing Innovation Center. This collaborative effort aims to empower manufacturers in enhancing decision-making, predicting challenges, mitigating issues, improving efficiency, and optimizing manufacturing operations. This is achieved through the innovative use of semantic information models and AI and ML-powered digital twin solutions. Welcome, Dr. Ragu Adinarayanan. So I wanted to start with something on a lighter note. So Professor Ragu, could you share with us something that you feel like people would not know from all the accomplishments and the achievements that you have in your bio?
Yeah, well, thank you, Rajesh, for the kind introduction. Good morning, everyone. It's my pleasure to be here this morning. So, as you heard Rajesh mention that, my background is really in electrical engineering, but since I started my career 30 years ago, I've been in higher education for 30 years right now. I've always been very passionate about manufacturing. So, and throughout my career, I have spent about 17 years of my academic career in academic administration. So I have propagated a lot of these ideas on how we can enhance manufacturing in the U.S. So, that is a pathway that I've been taking throughout my career, and most likely that's the way I'll end it when I retire from Purdue. And I've done a lot of these talks, and sharing some best practices that we have done here at Purdue University, to industry partners. I work very, very closely with industry partners. I was just telling Rajesh before this call today that I spend about 75% of my time interacting with industries because they play a very huge part of my day-to-day activities. And a lot of what you're going to be hearing me talk about today is how we have engaged with industry to build a very transformative and a groundbreaking kind of a program, one of a kind in the US.
Th- Thank you, Professor Ragu. Yeah, that's what I've been very impressed with what you've been doing there at Purdue, and I'm glad I'm excited that our listeners will get to hear from you as well. So just to get started, maybe could you help demystify like what is smart manufacturing, right? 4.0. There's been all these transformations so far. So none of the technologies are probably new, right? Like robotics, automation, and so forth. So could you tell us like what's different and how is manufacturing being transformed?
So, over the last 10 years, we see the word 4.0, uh, more accurately, Industry 4.0, floating around anywhere we mention or use the word advanced manufacturing. So, this is a concept, strategy, philosophy, whatever you choose to call it, which started in Germany very soon after the 2008 2009 financial crisis. So the Germans came up with a strategy on how we can how they could revitalize their economy through manufacturing. As we know, manufacturing is a huge contributor to their GDP. So naturally, this is something that they chose, to seek some kind of a transformation on. So this concept very quickly caught on around the world. So if you look at countries like China, it is referred to it as Made in China 2025. I'm sure many of you have heard it. And then in the US, we call it smart manufacturing, and by many other names around the world. But philosophically, strategically, and conceptually, it all means the same thing. So regardless of what one chooses to call it, it has become widely accepted today as the fourth industrial revolution, which is really the next installment of the digital transformation of the manufacturing sector. So the last time a transformation happened uh, was in uh, was around the 1969 1970 time range, leveraging a lot of the spin-off technology that came out from the space race, that gave rise to a lot of the logic processors, PLCs, robotics, and also automated production. Now we fast forward 50 years, 50 or 55 years, IoT really burst into the scene right around 2013, 2015, and data and connectivity became the new currency. I use the word currency because, it is, I would say, in my opinion, it's one of the major enablers of Industry 4.0. So it's the currency that drove many of the disruptive technologies that we see today that has enabled the 4.0 transformation or the industrial revolution as we see it today. So today, when we say smart manufacturing, it is manufacturing 3.0 plus additional capabilities and technologies that is enabling it. So when we say 4.0, it doesn't mean that we are throwing out what has been 3.0 and what has brought us so much of prosperity from 3.0. We are not throwing that away. We are just adding on. We are building on what is 3.0, using technologies like the Internet of Things, artificial intelligence, machine learning, big data, analytics, and automation to enable data-driven products, data-driven processes, all this to achieve new levels of efficiency, productivity, flexibility, sustainability, and resiliency, including in the supply chain, right? So when when this concept really took got the attention of the U.S. In the U.S. around the 2015 2016 time range. So it takes a little bit for things to catch up in the U.S. That's something I noticed. It always happens much quicker in Europe. And so in 2016, NIST looked at the economic impact, right? So the concept of 4.0 or smart manufacturing is still fairly new in the US. So NIST very quickly, the National Institute of Standards and Technology, they very quickly conducted a study. And from that study, and this is a 2016 study, they said that smart manufacturing is estimated to bring about $57.4 billion in prosperity to the US manufacturing economy, right? And then very soon after that, McKinsey did a similar study, and they said that both data, connectivity, IoT, and AI, its impact on the manufacturing sector would bring about 50% reduction in the cost of inventory, 20% reduction in the cost of quality, 55% increasing in productivity, and 50% reduction in downtime. So and so in very soon after that, Accenture wanted to do their own study, and they said that data alone will boost global productivity by 1.2% annually, increasing the size of the global economy by $13 trillion. So the impact of smart manufacturing is definitely not questionable, and which is the reason why whether we call it Industry 4.0, smart manufacturing, or whatever it might be, the impact has been realized, and we see more and more industries are moving towards that.
Oh, yeah, thank you. That's a nice way of putting it. So, like you said, it's building on top of the previous transformation or Industry 3.0 revolution, right? So, it's adding all this new technology, whether it be additive manufacturing, like 3D printing and things like that, right? Data and connectivity, which you called as like the currency of today. I see that as well around. It's helping improve quality, improve the efficiency of the manufacturing processes. So I guess if we kind of like look at this rebirth of manufacturing that's happening right in the U.S. With being fueled by the government through all the different policies and acts and the abundance of technology here, could you tell us a little bit or walk us through what are the types of roles that you see in the manufacturing floor that didn't exist before, and therefore like what skills are required?
So I like the use of the word rebirth of manufacturing. So manufacturing has always been here in the U.S., but it's taking on a whole new persona. That's the way I look at it. And it's it is really rethinking how we are. I mean, it's really rethinking the strategy, the manufacturing strategy for the US. And really what brought this about, you mentioned Inflation Reduction Act, CHIPS Act, and the like. So it was the pandemic, right? After the pandemic, it brought to light a lot of previously unseen vulnerabilities, and it's got magnified. All the problems that existed within the system, our ecosystem of what we had as manufacturing really came to light, and we saw what happened to manufacturing during the pandemic, and particularly with the supply chain. Okay, so it used to be that prior to the pandemic, it used to be a simple matter of outsourcing production to other countries, have them manufactured and ship them back to the US, And another well-known strategy is to deliver materials just in time for American firms. Now, what we have seen during the pandemic and very soon after the pandemic, there was severe limitations to these models and to this strategy that US has been using for the last, 20, 30 years. So, although they have been highly efficient, right? Now we're out of the pandemic. Okay, even though those strategies are still highly efficient, but they are still very vulnerable to breaking down, in the face of another pandemic, another war, or perhaps even a natural disaster, right? So, which is why I said use the word strategy, right? So, beginning from 2022, the White House, they began, they assembled a group of experts and they began reimagining and reconstructing the manufacturing strategy, primarily to increase flexibility and also resiliency. So the CHIPS and the Science Act and the Inflation Reduction Act are all part of this realignment strategy. Yeah. So to your question as to what are some of the skills that are becoming increasingly important as a result of all of this? So let me just quickly say that the the Chips and Science Act alone, it provided 52.7 billion dollars to the American economy, particularly to the semiconductor industry. Uh, and part of these funds are being used for workforce development to support the integration of advanced technologies, right? So
Mhm.
technology, it's become a non-negotiable item, right?
Yeah.
That is impacting these industries. So what are some of the skills now? For the shop floor, even at the shop floor level, they all need basic digital literacy skills. Now, this includes tools and use of platforms with smart machinery, IoT devices, and also digital interfaces. So that is, the ground level, basic bottom line. And then more and more, we are seeing that data analysis and AI is becoming more and more important. In fact, I read a report just yesterday that shows that in the next 5 years, the growth of data analytics and AI, even for the shop floor workers without college degrees, is going to increase by 300% or more. Right. And now, why is this happening? Because we have the influx of data. Data is uh, almost a commodity these days because of the availability of data from IoT devices. So, they are requiring shop floor workers to be able to analyze and interpret data in real time, not at the end of the week, but to be done in real time. The other thing that we are seeing is that for companies who want to, adopt many of these technologies, particularly around data, connectivity, they may or may not have their own IT departments, right? So the cloud and the edge is becoming the go-to for many of these companies that cannot afford to run their own IT department. So with the
Mhm.
cloud and the edge, we have they can get access to scalable storage, scalable computing, and they can use a lot of these services that are available in the cloud to analyze, to process, and also to analyze the data. Plus, in addition to that, it allows for remote monitoring, real-time collaboration, and also access to advanced software tools and services. Uh, I would also stress that with the increased connectivity, the shop floor worker, whether they are frontline worker or they are an engineer, they have to have cybersecurity awareness,
Mhm.
particularly with increased connectivity. It also comes with the risk of cyber threats, and also shop floor workers need to be aware of cybersecurity best practices and protocols to protect not just the data, but also to protect the OT systems from cyber attacks.
Mhm.
And last but not least, robots. You mentioned robots. So robot came about, during the third industrial revolution. We've had that for many years now. But what is new today is the collaborative robots and autonomous robots, and these are, you can call them intelligent robots. So workers today have to be working alongside these robots, working collaboratively with robots. So, not only they need to know how to program them, but also to, how to, uh, you know, uh, monitor and collaborate with these robots effectively.
That's correct. Yeah, that's true. There's, as you said, I was also reading a similar report in that World Economic Forum, like that AI and big data skills are going to be increasing, right? Something that everybody needs to reskill, and technology literacy is something is going to become a bare minimum skill, right? Must have for everybody, I guess, involved in any discipline. So I know you had some slides to share as well with our audience, right, Professor Ragu? So why don't you take us through what is Purdue actually doing, and can you talk us through the curriculum that the smart manufacturing and industrial informatics curriculum that Purdue has built to address this
Okay.
skill gap?
Yeah. I'll be glad to do that. So I'm going to share my screen. Let's see. And please let me know if you see it. Okay. Let me know if you can see my screen.
Yeah, I can see your screen.
All right. So, for us, the manufacturing digital transformation journey started back in 2018 at Purdue University. So just about the time when US is beginning to embrace Industry 4.0, uh, I came to my senses and I stepped down as a department head after serving in that role for 17 years. And like I said, I was very passionate about manufacturing, and as soon as I stepped down as a department head, my boss or my dean offered me to go on a sabbatical for 6 months paid leave and all of that. So I said, well, rather than doing that, why don't you, fund my trip to Germany so that I can go to the birthplace of Industry 4.0. Not so much to look at what they're doing in manufacturing, because I got a pretty good idea as to what they were doing. I wanted to see how the higher education institutions in Germany have adopted Industry 4.0 into their curriculum and into their programs. Because even today, if you look in US, many manufacturing programs are still unfortunately stuck in Industry 3.0. Not that it's bad, but you know, we at Purdue felt that it is not going far enough. And there were a handful of universities that that were transforming their higher education, perhaps course by course, right? Or maybe modules within a course by introducing, elements here and there. So for the most part, they were just doing things at the fringe. So, I felt, if you want to go through a true transformation, then, we needed to do something more than that, right? So, uh, you know, uh, uh, I'm sure there are many manufacturing folks on this call, but really what the motivation was, after I made my trip to really bring this change into Purdue, I mean, Purdue is an institution that's been around for more than 150 years. Any change is sometimes difficult to come by, as big as Purdue is, and also as long as it's been established. So there was a study that came out in late 2018, early 2019 by Deloitte. And they worked with the Bureau of Labor Statistics and all of that. So that study actually pointed out that between 2018 and 2028, 53% of all open positions will lie vacant and unfilled due to skill shortage in the US, right? And then 2021 pandemic hit, and there was a survey from Gartner that came out that says that the manufacturing leaders feel the organization lacks skilled workers. Not to mention they didn't have workers, period, right? Many of them had challenges just even getting workers. So they felt that they, even though they had the desire or the intent to engage with some of these smart technologies, but they just didn't have the skilled workforce to enable them to do that. So we decided that Purdue is going to be doing something about that. Maybe it would be even be a leader. Uh, so if we do change, what is the change going to look like in our curriculum? So taking a very holistic view, you know, uh, we felt that we have to address some very critical items in our program. For example, connectivity, virtualization, data utilization, IoT, AI. I mean, you probably can see my slide here. I don't have to read it to you. And make a wholesale transformation. Let me see if I can get.
Oh yeah. So there may be one probably. I think we are seeing your slides. If it's in
Oh, okay.
presentation mode, we're probably not seeing that screen, Professor.
Oh, you're not. Okay, they're not seeing the screen.
Yeah, I think we're not seeing them in presentation mode. Yeah.
Oh, you're not seeing in presentation. Okay, on my screen it is presentation. Hold on a second. So you're not seeing it in presentation mode, right?
Correct. Yeah. So I think you've as you flipped the slides, we were just
Okay.
seeing the
What about
your
what about now?
yeah. Let me see.
Is this good?
Not yet. Could you try sharing your screen again?
Okay, let me do that. Okay, let's see. Hmm, hold on. Okay, all right. Share screen. My apologies.
Yeah, that's not a no problem. Yeah,
Okay,
okay.
you can see
So I
this?
see. So I see the like just the slides. But if what we can do is if you went into presentation mode and you click on
Okay,
the slideshow menu in PowerPoint, right? I think
right.
it'll let you change the screen.
So I'm doing exactly that.
Okay.
So you can't see because I'm looking at
The
the
presentation.
presentation mode, right?
Okay.
So you still can't see my presentation mode. Is that correct?
That's correct. Yeah. You
Ah,
st-
so
I can see your slide. Maybe if we just flipped through the slides right in your slide deck, we could probably yeah. I think now I'm
okay,
seeing slide number three. Yeah,
okay,
and your cursor. So I think we can probably stay here.
all right. So let me make it a
Okay.
little larger then. Sorry, I think there's a little glitch and
Okay.
it's not allowing me to. So anyway, what I was saying is that we need to do a wholesale change, not just at Purdue, but across the US, right? All the higher education institutions. We feel this is not just a requirement, but it's a moral obligation, as we are preparing the next generation engineers and the like. It's our moral obligation that we are preparing them for the jobs of the future that are already not even in the horizon, they're already here. The future is already here. Uh, and what so we so my next slide. So this is me when I went to Germany in 2018. So I actually looked at what the Germans were doing, and tried to bring some of that knowledge back to the US. Something that they were doing related to smart manufacturing and smart manufacturing education is only being done at the graduate level. Right now, we all know that we all know that in Europe and for the most part of the rest of the world, education is pretty much free. But in the U.S., even though you're in a public institution, right, education is not free; it's only subsidized. If somebody comes to a place like Purdue, the state subsidizes education by 20 or 30%, and the remaining they have to pay out of pocket, right? So we figured that if we did what the Germans do by focusing on only graduate education, we will not build the necessary pipeline to produce the number of graduates to go into manufacturing. Not to mention there are fewer and fewer people going into manufacturing, and we don't want to further constrict that pipeline. So, uh, while we took a lot of the advice and a lot of the strategies that the Germans were using in higher education for smart manufacturing, we felt that we had to do it at the undergraduate level. So In 2019, uh, in 2019, we had a summit on campus where we brought in some of our key stakeholders here at Purdue, Microsoft, PTC, Rockwell, uh, you know, and Caterpillar and the like. We developed some projects and goals and objectives on how we're going to address very holistic change to the curriculum. And then we were also introduced to Department of Energy and the Clean Energy Smart Manufacturing Institute, who provided us with the funding to help us develop this program. In fact, they are the one who seed funded the development of this program. Now, you might wonder, so why is DOE and the Manufacturing USA Institute, particularly the Smart Manufacturing Institute, was interested in what we were doing? Because by that time, they were already realizing that manufacturing in the U.S. is, you know, uh, uh, it's very prone to be quote unquote dirty. All right, we produce a lot of greenhouse gas emissions, and more than 30% of all the energy that is generated in the U.S. is being used in manufacturing, and is the largest contributor to greenhouse gas emissions. So the idea behind them funding a program like us behind smart manufacturing, even though it's an unspoken truth, smart manufacturing actually, like I mentioned earlier, increases productivity, increases efficiencies, improves quality, reduce waste. All these are going towards meeting sustainability metrics. So which is the reason why DOE and the Smart Manufacturing Institute took a lot of interest in what Purdue was doing. So they actually help fund this curriculum that we have developed here at Purdue. So we worked with industry. We looked around the US to see who else, was approaching, the transformation of undergraduate manufacturing education as holistically as we were thinking. Unfortunately, we could not find anybody. So we worked very closely with our industry partners to come up with some frameworks to guide and inform our transformation, because there's no benchmark that we found around the US to help us go through this holistic wholesale program, undergraduate program transformation, all the way from freshman to senior year in college. So so we came up with the BS in Smart Manufacturing Industrial Informatics degree. And we introduce classes, like, for example, I'm sorry if you can't read this very well. Let me see if I can make it a little bigger. uh, we came up with classes like industrial IoT 1 and 2. 2 is mostly focusing on cybersecurity, cloud computing, manufacturing cloud computing applications. Now, if you ask me, if we would see classes like this like 10 years ago, I would have said probably not, right? And things like modeling and simulation, where we discuss digital twins, mixed reality, metaverse and smart manufacturing, intelligent manufacturing, machine learning. So the list goes on and on, right? So this is what our transformation looked like as far as what the new course is now. I should also say that this was not intended to totally wholesale replace what was 3.0. So, we are essentially building on what was 3.0, right? So, and this is what a typical class, in manufacturing look like, in our program, where we're using artificial intelligence, IoT, big data to enable things like predictive analytics, machine learning, optimizing production, improving productivity, and so on and so forth. So, all these was developed with the help of funding, as I said, from DOE and also the Smart Manufacturing Institute. Now, also, we reimagined our strategy for how do we create the facilities for students to really get an immersive experience around these new technologies. Because when I went to school, we had quote unquote laboratories, right? Where, we had one-off machine that we are, going to be using for the rest of the semester, right? Whether it's an oscilloscope or a breadboard maker or things like that. So we very deliberately design the experiences. So, for example, you probably can't read this, but I'll just read this out to you. One of the things I'm going to look at. So, in the smart learning factory, right? So I say factory because these are actual production facilities that we've created. One is the smart factory, the other one is the smart foundry, and then we have an intelligent process laboratory, and then uh, I think I just negated myself. It's called the laboratory, but it's really a production facility. And then we do have a true IoT laboratory. Now, we are introducing things like cloud and edge computing, data analytics, human machine collaboration, autonomous human machine robot systems, cyber physical systems, and the like. Now, we also worked very, very closely with Microsoft to build a cloud infrastructure so that students can actually experience and and have the build and build competencies around cloud and edge computing, right? So we connected our foundry, our process manufacturing, our factory, and the IoT lab all to the cloud and also to the edge devices. So that is what we have done on the education side at Purdue.
Yeah, this is amazing. That's a lot of times there are a lot of technologies, right, open source and so forth. I think this presents a nice landscape or framework, as you put it, right, for somebody who's wanting to look at it. What are the technologies and what maybe things out there that are available that we can plug and play. That's right. So I like what you kind of also mentioned about sustainability, right? That the impact of all the smart manufacturing. I just wanted to highlight one of these things that I read about as well. Now, a lot of these factory floors are being equipped with technology, right? Either with displays and all that, just simply displays. And the simple fact that we are going from printed work instructions to digital work instructions, that itself has a tremendous impact on sustainability, right? The amount of
Absolutely.
paper that needs that the less has to be printed and all that, and then they're talking about lights out factories and so forth. So could you share with us some success stories, some of the research areas that Purdue is involved in?
Okay, so again, I'm going to share my screen here,
Okay.
if that's okay. All right, let's see. So another success story we wanted to share with you is as we were doing this project, we had like 15 or 20 industries that we were. By the way, can you see my screen?
Yeah, I can see your slides. Yeah.
Okay, all right. Can you see it in the presentation mode? Are you still seeing it in the slide mode?
Slide. Sorry, in the slide mode, we're seeing that
Okay,
portion. For some reason, it's not
got it.
showing
Okay.
us.
All right, so let me then make it a little larger. So, you know, like I said, when we started this journey back in 2019, we were working with a large number of industries, mostly big industries, big companies, tech companies, and industries alike. So, you know, these companies were getting excited. Okay, you're creating this 4-year degree program, great and fine, you know, but by the time you produce graduates, right, it's going to be taking 5-6 years, perhaps even
Yeah.
longer, right? So they say, what
Hmm.
can you do for us now? Right? What can you do
Yeah.
for us now to
Hmm.
upskill and reskill their workforce? Because many of them are not going to be going back to college. So, at their urging, we approached, when I say we, me and my team of faculty members who were, developing this project back in the 2020, 2021, we approached DOE and also to the Smart Manufacturing Institute. We said, how can we would like to democratize what we are doing at Purdue so that not just the students at Purdue can benefit from the type of things that are being done here, but we can take it to the shop floors of the industries, right? So we so they requested us to submit a proposal so that so that we can apply to become one of the centers. So they call it the Smart Manufacturing Innovation Center. This is more of a outward looking. A lot of what we do on the academic and research side is more inward looking into Purdue, but this is more of an outward looking entity that we established. So we actually uh, so we actually put a proposal together, and in 2021, in 2021, the U.S. Department of Energy announced the expansion of their smart manufacturing innovation centers. Now, these innovation centers, there were already about four of them in the US or three of them in the US already at that time. So when they had the call for proposals, they added four more because they saw more and more industries are adopting smart manufacturing, and there has to be some means of providing this knowledge and technology for them, right? So Purdue was one of the universities selected in that round. So today there are seven universities that does this around the U.S. One is UCLA, Rensselaer Polytechnic, North Carolina, Case Western, Penn State. This is a private company actually, and then Purdue University. So we are kind of like a lighthouse center. Our goal is how we can help U.S. manufacturers implement smart manufacturing, optimize the use of energy and materials, and prepare high-skilled manufacturing workforce. So that is our charter, right? And given that we put this proposal uh, during the pandemic, we felt that there has to be some good use cases that we can showcase, that can bring value, particularly to the Midwest. So if you talk about the Midwest, there's a lot of CNC machining industry, metal casting industry, because we're in the heart of the automotive here, uh, and also supply chain. We all know what happened to supply chain. So I figured that Purdue cannot do it all alone. So we went and recruited some partner universities to be a part of this project, so we can cover a larger area. So Purdue took on the metal casting side of things to showcase how uh, smart manufacturing can transform this industry, right? So, because and also metal casting is very important in where we are. Like I said, we are close to a lot of automotive industries, and if you think about it, right, 90% of all durable goods have metal castings in them, right? And of that, 30% goes into automotive. So, even though it's not very often thought about industry, but metal casting is very important to the Midwest. So we took on the use case of how we can showcase and feature smart manufacturing, AI, IoT, you name it, into metal casting. And then I worked with my colleagues at West Virginia University, who is a satellite to our center at Purdue, to tackle the supply chain. So you heard me mention about building resiliency in the supply chain, right? So how can we predict what might happen in the future based on what we know presently, and also what we know historically. So my partners at West Virginia University were tackling of sup- that aspect of manufacturing, which is supply chain, through the use of smart technologies. And then I have another colleague at the University of North Florida, who was very focused on machining. Machining is also very important in the Midwest, and so he was very much focused on zero defect manufacturing. And and then we had both Microsoft and Caterpillar partnered with Purdue in establishing the center. So I would say that is one of the success stories that we've had at Purdue, because we felt that beyond what we can do to prepare the next generation workforce, we successfully established a center so that we can democratize a lot of these technologies that are still which are still very foreign to many industries, so that they too can enjoy the benefits of using these these technologies.
Yeah, thank you for sharing that. I think there was one question that I see in the question panel. Um, James was asking if you could show page 2 from your earlier presentation.
Oh, okay. This current presentation or the earlier
The
presentation?
the earlier presentation.
Okay, let me
Yeah,
see. Which two? Okay. Oh no, sorry, wrong one. Okay, give me a second.
sure. And for the audience, please, you can type in your questions in the question panel, and we'll address
Page
them.
two. Okay, there you go.
Yeah,
Yep, that's it. Is that it?
yeah. And so this is page 2. So James, if you think that's the one that you wanted to see, this was like, I think, proof points of uh, from the study, even from the World Economic Forum, they were saying a lot of the jobs would disappear, right, and would be replaced with new skill sets. So I think you were showing
Yeah. Uh-huh.
or the skill gap. Mhm.
Yeah, actually there were two things at play here, right? So the skill gap is growing. Okay, so that's one thing. Uh, which is a problem, right? The other thing is that, we all hear about the great tsunami, and
Yeah.
probably have heard to it as being referred to as that. The great tsunami is the retirement of the baby boom generation, right? So
Hmm.
with the retirement of the baby boom generation, that will compound the skills gap that we are already creating, right? So,
Correct.
you put two and two together, we have now really compounded the problem even further.
Correct. Yeah, exactly. Yeah. And there's that transfer of knowledge, the tribal knowledge sometimes, right, is lost because
Absolutely.
they've not been captured in a manner that if it was not human to human transfer, that it's like it's lost, right? It's not documented anywhere.
Right, right. So, keep in mind that this, when I showed this 53%, this study was conducted before the pandemic, right?
Yeah.
This was conducted before the pandemic. Now, after the pandemic, we saw what happened, right? There was a
Mhm.
huge problem with workforce shortage. So this is, I can bet you if we look at the data today, it's going to be more than 53%. And tie that
Correct.
to the fact that there's a lot of investment, capital investment by companies into technologies. They need workforce to enable and operationalize and use a lot of these technologies.
Nice. I'm glad when you showed your success stories in the collaboration. You had North Carolina State. That's my alma mater, so I'm proud of them being on the list.
Wonderful.
So I guess I wanted to, I'm still waiting for questions here, but this was quite interesting in the uh, list of technologies that you had shown, right? Like there's connectivity, there's visualization, primarily coming from that data insights, right? So collection of data, data ingestion, uh, synthesizing that data and presenting it back, right? What can you tell us a little bit about? Like I think you mentioned slightly, there's a lot of integration also happening with OT systems, right? Business logistics with the operation, like manufacturing execution systems, if you will. Um, what are you seeing in that area in terms of like maybe collaboration between product development systems like PLM and ERP technologies or MES?
Yeah, so the success of all these systems, right? That you
Mm-hmm.
just mentioned, if you want to look at it end to end, right? If you want to look at
Mm-hmm.
it end to end, and some call it the digital thread,
Mm-hmm.
right? Some call it the digital thread, meaning all the way from design, cradle to grave. Now,
Yeah.
I use the word cradle to grave with my German colleagues when I visited there in May last year.
Mm-hmm.
They said, "Oh no, no, please don't call it cradle to grave. We don't want anything going to the landfill." So they don't like use of the word grave. So they're already moving into Industry 5.0, which I
Mm-hmm.
won't call a transformation per se. It is more a another evolution of 4.0 where they take into they pay a lot of attention to sustainability and also the resiliency. Now,
Mm,
going back to your question earlier, right? The connectivity, virtualization, and data utilization. All right. And,
mm,
that can only happen if you can have visibility into the entire system end to end,
yep.
right? Even for supply chain. And, that is one challenge, I think, whether you're looking at the semiconductor industry or just any industry in manufacturing, supply chain still is a big problem, right?
Mhm,
I don't think they've fully addressed it. So the resiliency of supply chains is among the top, jobs that are coming up as far as how can we leverage a lot of these technologies so we can have, full visibility
mhm,
into, someone's operations, whether you are an OEM or a tier one or tier two supplier, right? So that
yeah.
if you are predicting something is going to happen, all right. Now, the good and bad of data, I said data is the new currency in manufacturing, right? The good and
Yep.
bad of the data, when you combine that with AI, it gives you a very important capability where not only you can see what is happening, but you can even predict what is going to happen, right? So and that can, so by having this visibility and be the ability to collect and analyze the data, okay, you can better manage the risks, okay.
Mhm,
You may not prevent it, some of the challenges that they might face, but you can better manage a lot of the risks that are happening in the supply chain.
correct. Yeah. Very true. Yeah. I think that's what with even business model changes, right? Like just simple fact that from production models like engineering to order to assemble to stock and so forth,
Correct.
as they're collapsing the manufacturing process, they're having that end-to-end visibility to be able to react. Because again, you don't want to, let's say, rotate to the side of excess inventory and all that, right? I think you still
Yeah, yeah.
people want to follow lean processes, but
Mhm.
be able to react to. Mhm.
So, I think that's where, that is one of the shortcoming of lean. Again, I
Mhm.
love lean. I think lean is more reactive,
Yeah,
in my opinion, and I could be wrong because, you're collecting lots and lots of data, and you're looking retrospectively as to what happened and what can we do today so that it doesn't happen tomorrow, right?
right.
But
Correct.
so that is more a retrospective perspective of how we use lean. But I think lean is going to be evolving so that we can now, using historical data, looking at what is happening right now, and looking we can predict the future, right?
Yeah.
Okay, we can, to some extent, predict what's going to happen into the future. So I think this ability to react and manage challenges in real time is what's going to be the key to building
See, yeah.
resiliency in manufacturing.
Yeah, well said. Yeah, correct. I know we have the last 5 minutes. So, as closing remarks, Professor, like we have a lot of engineers on the call, I'm sure managers as well, right? Who are look either their business partners are folks on the manufacturing side, and they may be on the engineering. So, as closing remarks, what would you what could you tell them? Like, how can they benefit from the work Purdue is doing?
Well, we I think today I'm happy to say that Purdue is not the only university, at least on the engagement and the outward facing side, is doing what it's doing today, right?
Mhm.
There are many universities that are, doing more of the outward facing. I think one of the reasons is because there's a lot of money out there,
Yeah,
uh, from the Chips and Science Act, and from the Infrastructure Reduction Act, and all of that. So there's a lot of money to be had. So, I would say, reach out to your, if not Purdue, reach out to your local university to see what they are doing, and perhaps collaborate with them and give them ideas on how they can improve. They might give you ideas on how you can improve, because this back and forth is what helped us here at Purdue to build what we have today. I can tell you one thing: we could not have created what we have done here just by ourselves. Okay, it was a partnership with our industry, partners, that we've been able to achieve, this level of success. Right? It was with the help of industry. We could not have done this alone. So, similarly, I think you can help, whichever universities you're close by to, or pick one, help them go through this transformation. Like I said, all higher education institutions, particularly the public higher education institutions, we have an obligation to make sure that the next generation, engineers, technicians that we are producing, will have the skill set, right? If they have not started the journey, maybe you can prod them. So, I think engagement is key. And I think this is another way we can help with building the resiliency in our manufacturing supply chain.
Right. Thank you, Professor. So, for all the audience, thank you for joining. This is one in a three-part series. The first on people. I'd like to explore further, like the processes, the process areas, and then even the technology. Right, try to dive deeper into the technologies that Professor Ragu showed us today. So, I hope to see you there. So, thank you, Professor, for all the insights and the wealth of information you shared with us today.
Thank you so much, and have a good rest of your day. Thank you.
Thank you.